Now going over to question number 22. This is a super scary, intimidating question because of just all the stuff that's written in there. But there is one critical name being dropped, and that is the word vertex. Let's talk for a moment about the vertex of a parabola. If you have a parabola in the ABC form, the x value of the vertex is negative b over 2a. So for instance, if we had 5x squared plus 6x plus 7, the x value of the vertex is going to be negative b over 2a, which simplifies to negative 3 over 10. Now, if it's in a factored form, let's say it looks like this, y equals 2, x minus 5, x plus 3. Well, let's think about the x-intercepts right now. The x-intercepts are where y is 0. So y is 0. And now we would use the zero product rule, where you take each piece and independently set them equal to 0. And we get x equals 5, and x is negative 3. Thinking about that visually, 1, 2, 3, 4, 5, 1, 2, 3. These are the x-intercepts for the parabola that we have right now. And parabolas are symmetrical. So if we draw a parabola in this spot, we can see that the x value of the vertex, this is the vertex right here, the x value is going to be, just by the picture, at x equals 1. But the point is that it's going to be exactly in the middle between the two x values. So if you've got x equals 5 and x equals negative 3, we can do the average. 5 minus 3 all over 2 is going to give us 2 over 2, which is 1. So that was actually perfect. The axis of symmetry is at x equals 1. Now, the way this relates to the question that we're in right now is that we can take advantage of the symmetry of the parabola in more ways than one. For instance, let's say that we said the height at x equals negative 4 is equal to the height at x equals 6. So you have a height right there and a height right there. I could find the vertex just as easily if you told me the height at negative 6 equals the height at 4. I said it backwards. I could find the vertex just as easily if you told me that the height at negative 4 is equal to the height at positive 6. Because, like we said before, parabolas are symmetrical. So if both sides of the parabola are hitting some horizontal line that's not the x-axis, it's going to have the same effect. The x value of the vertex is going to be halfway in between those two intersecting points, which once again is 1 right there. So we can take advantage of the symmetry of parabolas by taking the average of two x-intercepts or the average of 2 points on the parabola that have the same height. Of course, the SAT is big on the f of x verbiage. So on a real test, this would probably look something like this. F of negative 4 equals f of 6. And you have to have watched a lot of SAT videos to realize that they're kind of giving you the vertex when they do that. So let's bring it over here. Here, we're seeing f of negative 9 equals f of 3. So let's imagine that. XY axis, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Then we've got a vertex. We have a parabola with the vertex kind of somewhere around here, halfway between negative 9 and 3. So the x value of the vertex is going to be the average. It's going to be right in the middle between those two x-intercepts, just as far this way as it is this way. So that's going to be negative 9 plus 3 all over 2, which is negative 6 over 2. So that's negative 3. X equals negative 3. So we now know that the x value of the vertex is x equals negative 3, but the other formula for finding the x value of the vertex was negative b over 2a. And so that should also be equal to negative 3. So now we have an equation that can kind of assist us in what we're doing. Maybe multiply by 2a on both sides, and we'd get negative b equals negative 6a. Divide both sides by negative 1, and b equals 6a. Now by b, what do we mean? This is an ABC parabola, like every parabola, if it's in the standard format. And by b, we're talking about this number right here. So b is 4. And we just figured out that that's also equal to 6a. So a is 4 divided by 6, if we divide by 6 on both sides, and it's 2/3. So we know that a is 2/3, and therefore it can't be greater than or equal to 1. By definition, it's less than 1. Now, what do we know about c here? Unfortunately, nothing. And it sounds like a cop-out, but this is our least favorite math question. And the same thing kind of happens in verbal. Sometimes we call these like a non-question. What I'm saying is there's no way to know what C is. We know that we have this parabola that's centered here, but that parabola, it could very well be all the way up here, centered in the same location. It could very well be all the way down here. We know how this thing is centered left versus right, but we don't know how high it is. Now, the reason that matters here is because for a parabola in the ABC format, we know that the A is the opening direction, the B is responsible for our lateral movement, and C is our y-intercept. So in the question, we're being asked about C. We're being asked, what's the y-intercept? And because we don't know how high or low this parabola is, we're going to have basically no idea. Is the y-intercept here? Is it here? Is it here? We have no way of knowing. So look at the wording of the question. It says, which of the following things must be true? In the world of math, there's a huge difference between saying must and saying could. Which of these things must be true versus which of these things could be true? Well, C could be a negative number. In the orange and pink parabolas, it is negative, the y-intercept, but it also could be a positive. So we can't say that C must be negative. So we can't say number 1. And we also, from what we talked about before, we can't say number 2. So the answer here is a non-answer, which is really tough. You have to be very confident to be able to pick answer choice D on this question.